Well, hello, welcome back. We're starting a new unit today, which probably seems like a good time because we just finished break and it's just a good time for a fresh start. And this particular unit, I'm going to use the title Forces, but we're going to start, instead of talking about forces first, we're going to start with another type of motion, something we didn't include in the last unit on motion, and that is a type of motion called acceleration. So we're going to just call that part one. In fact, the first few parts of this unit are going to be about acceleration. But today we'll get an introduction to what that is. The next couple of days we'll go in a little bit more depth on different aspects of acceleration, and then eventually we will tie it into the idea of forces. Okay? So let's start with just a general definition. And I'm one that uses more descriptions rather than definitions. Like, this isn't something you'd look up in Webster's dictionary, or probably if you Google it, you'll find something close to this. It is defined as the rate of change in velocity. So you see we're tying it back to velocity, and that's a definition that we had in the previous unit. Okay? So let me refresh your memory. Velocity described two different aspects of some object's motion. One is how fast it's moving. We could call that the speed. And the other, and people forget this a lot, is the direction that it's moving. Direction is also part of velocity. So if either one of those things change, the direction or the speed, then we say we are accelerating. And when we say the rate, that means the more rapidly the velocity changes, the higher the acceleration. Okay? So let's just maybe write that down. High acceleration, I'll use an abbreviation, a little easier for you to write, means that velocity changes rapidly. Just a way for you to kind of picture this. If you've ever ridden roller coasters, they are all about acceleration. Okay? So when your velocity or when your motion changes in any way, maybe you're rounding a turn, maybe you're going down a hill, the more rapidly that happens, the more you feel the acceleration. And your body is very sensitive to acceleration. You feel it because the muscles inside like kind of stretch and things move around, and that's that feeling you get inside. If you've ever been on a plane, most of a plane ride, hopefully, is pretty smooth. It's a steady velocity, and you don't feel much acceleration. But the three times you can feel acceleration are when you're taking off, it's a very rapid increase in speed, or when you're landing, a very rapid decrease in the speed, or if you get some turbulence, a slight change in direction usually, a little up and down motion. And your body, again, is very sensitive to that. So any of those things can be considered acceleration. So maybe let's write that down as well. So those things that I just said, we'll just list, can include getting faster, or getting slower, or changing direction. Now, I'll bet if you ask 100 people on the street, what does acceleration mean? They will tell you, mistakenly, kind of the everyday definition, but not the sciencey definition. They'll say, oh, it's when you're getting faster in your car. The pedal, the gas pedal, is sometimes called the accelerator in a car. But in science, I need you to make sure that you include both getting slower and changing direction, along with getting faster, as three possibilities for how you can accelerate something. And very commonly, two things can happen at once. It can change direction while getting faster or change direction while getting slower. Okay? So don't be caught by the common everyday definition of just getting faster, but instead think of any of those three as ways to accelerate something. Okay, so I'm going to show you how to calculate acceleration. Keep in mind, this is not just a description. This is actually a number. So you can put a number on anything that's accelerating. A little out of focus here. Let's see if we can get that better. So I'm going to show you the formula that we use for this. I'm going to show you an abbreviated form using just letters abbreviation because to write out all the words would be kind of difficult. But you do have to know what these mean. So remember, when you do a problem, in here, you always show the formula first. All right, so get used to writing it this way. So we'll call the acceleration A. And so we're talking about a change in a velocity. And so what we write is we call these subscripts. You may have seen these in math before. So V stands for velocity, but there's two different velocities. There's the initial velocity, like what you start out at, and the final velocity, what you end with. And so we put little subscript letters. Don't write them as big as the V. Just put them a little small and a little below. So we say VF minus VI. Okay, the final velocity minus the initial velocity. Those would be numbers that you would see in your problem. And then you divide it by the time that it takes. This is why it's a rate. The rate means if it happens in very little time, that the acceleration will be very high. Okay, so a little bit more involved than, like, for example, the velocity equation, which was displacement divided by time. So let's show an example of this. So example number 1. An object goes from 10 meters per second up to 40 meters per second in 2 seconds. So you hear how we're describing a changing velocity. And we would be asked to calculate its acceleration. And when you're doing this on paper, again, always write all 3 steps. The formula with letters, then the substituted values, and finally the calculated answer with the units. Okay? So step 1 is just copying this. Get used to having that somewhere where you can find it. Maybe start writing in red here. We're writing it as a fraction. Okay? That's what the line means. So this is the top, VF minus VI, we call that the numerator, divided by T. T is the denominator. Now we're going to put in the numbers that go with each of these letters. So be careful. Final velocity, that's where it ends up in terms of its speed. So up to 40 meters per second. Include the units along with the number. If you leave those behind, you're going to get lost sometimes. And then we subtract the initial or beginning velocity. So it started out at 10 meters per second. Now if you put those in backwards, it's going to affect your positive negative sign. So don't get those backwards. Sometimes we'll have negative accelerations. I'll show you in a minute. Okay, T, how long it took. That's the time it takes. So 2 seconds. So there's our step 2, substituted values. And then we grab a calculator, and I'm trying to make numbers that are kind of nice for you to use just in your head. So first, the order of operation says we subtract the top first, then we divide. So 40 minus 10 would be 30 meters per second. And then we're dividing 30 by 2. So 30 meters per second divided by 2 seconds. Well, 30 divided by 2 is 15. And of course, these have units, probably units you haven't heard of before. Meters per second on top divided by seconds gives us a kind of interesting unit. We say meters per second squared. Okay? Meters per second squared. We just put a little exponent of 2 on the seconds. You could also say, some people like to say it this way, meters per second per second. I prefer the first, but I'm okay with the second form, okay? So that would be, and I like to box the final answer, then I know I'm done. Only box one final thing when you're doing a problem like this, otherwise it gets confusing for the person looking at it. So there's an example of an acceleration calculation. Let's do one more just to show you how acceleration looks when you're getting slower. Okay, here's example problem number 2. So what I want you to do is pause and write this down, and why don't you try to show in your notes yourself the 3 steps to calculate the acceleration, just like I did the last one. So write the same formula, substitute in the numbers, and then after you're finished, restart the rest of the video. I'll run through the answer probably kind of quickly since this is our second one, and you can kind of check yourself. I'm going to guess a lot of you will miss one important thing that's important in the answer, okay? All right, pause here, and then turn back on when you're ready. Okay, so I've got the first 2 steps written down, but I didn't write the third, okay? Because this is where a lot of you would make your mistake. And you can just fix it if you're writing in pencil or cross out. So here's the formula, same as before. Now here's what's different. It starts at 200 and ends at 0, or stop, we would probably typically call it. So the final velocity we put in is 0. The initial velocity is the 200 meters per second, okay? And then 4 seconds is our time. So do you see what's going to happen? The order of operations says we subtract up here 0 minus 200, which is negative 200, and then we divide negative 200 by 4, and we get negative 50 meters per second squared, or meters per second. That negative is really important because it tells us that the velocity went down. Okay, and that's what typically happens in these kinds of problems when something slows down. All right. So if you see a negative acceleration, not to worry, that can very well happen. Okay. Okay, so I think that's the last example I have. If you need to go back and see anything again, the beauty of this is you can rewind to that point and maybe go through a little faster. You increase the speed of the playback or something to hear what you missed, and always slow down on the parts where you think you get confused, because I'm going to have you do on your worksheet just the same kinds of things that you saw here. Okay. And of course, for those of you that are with us in the classroom, by all means, you can ask us for help. Make sure you've watched the entire video carefully and have your notes in front of you when you ask for help, though. Okay, that's it for now. Thanks for watching.